All right, here's an example where we need to get a common denominator. Notice we have two fractions, even though they're trigs, functions, they still have fractions. So I need a common denominator. So I need to multiply the left side by 1 plus sine A and the right side by 1 minus sine A. And if I do it to the denominator, I've got to do it to the numerator because that's a value, that's the same as 1, right? If it's the same thing divided by the same thing is always 1, and anytime you multiply 1 times something, you get the same result. So now I'm going to actually multiply it, and it is like a distributive property. I'm going to end up with this right here, 1 plus sine A plus 1 minus sine A. 1's not going to change those. And then I'm going to have 1 minus sine squared over 1 minus sine squared, which I could combine them like that. And look what I can do to the, oh, look what's going to happen to the plus sine A and the minus sine A are going to cancel. And the plus 1's become 2. Oh, what's 1 minus sine squared equal to? Think about your Pythagorean identities. That's the same thing as a what? Cosine squared. And, ooh, so now I've got 2 over cosine squared. I got to make it into a secant. Now think about it. Cosine is the same thing as what? 1 over secant. And then if I reciprocate that and multiply it, I'm going to end up with, you can't hardly see it right there, but it's 2 secant squared A is the actual answer. 2 secant squared A is what you end up with. It is the final part of that particular problem.